Welcome everybody. In today's video, we're going to learn how to find the distance between 2 points with an application of the Pythagorean theorem. Now, before we start, it is really important you watch our other videos on the Pythagorean theorem to properly understand and follow along. Now, we are asked to find the distance between points 3, 3 and -4, -2. Now, you might be wondering how we're going to apply the Pythagorean theorem in order to solve for this distance between these 2 points that we were given. Now, think about this for a second. The Pythagorean theorem only applies to right triangles. So you might guess that we are going to use a right triangle somehow to find this distance. Well, you're right. We're going to draw a right triangle such that the hypotenuse of this right triangle is the segment connecting the 2 points. Now, as you can see, we drew a right triangle over here, and if we know 2 side lengths of it, we can find the third one. Now, in this case, we're going to find the hypotenuse using the other smaller 2 side lengths. This is going to be C because it is hypotenuse. Now, first, in this example, we're going to count to find out what the side lengths are. So this would be 1, 2, 3, 4, and 5. So this would be 5 over here, 5. And then 1, 2, 3, 4, 5, 6, 7. So this would be 7. So in terms of the Pythagorean theorem, now we know what A and B are, and we can now solve for C. So 5 squared plus 7 squared equals C squared. Let's simplify this and we get that 25 plus 49 equals C squared. Let's combine like terms here by adding 49 and 25, and we will get that 74 equals C squared. We would take the positive root of both sides since we cannot have negative distances. Now this square root is going to cancel out the exponent, so we'll be left with C is equal to the square root of 74. So now we know that the distance between these 2 points that we were given is the square root of 74. Okay, let's do another example. This time we're asked to find the distance between 3, -4 and 6, 1. Let's get right into it. So once again, we're going to start by drawing a triangle, or a right triangle actually, so we can apply the Pythagorean theorem. And once again, the hypotenuse is going to be the segment connecting the 2 points. Now, this is a right triangle right here. Now, in this example we did before, we counted to find the lengths of the sides. But now think about this. We could do this another way using the x and y coordinates of both points. Now, let me show you how we could do that. So first of all, let's start with this side right here. It is a horizontal distance. So we could use x, the x values, to find the side length. Now also notice, so it would be the distance between this vertex and this vertex. Now notice, the point right here and this vertex both have the same x values, which would be an x value of 6. This would have an x value of 6, and this would have an x value of 3. So x value of 6, x value of 3. Now, if we counted, so 1, 2, and 3, we would have that this side length has a length of 3. Now, also, if we subtracted 6 minus 3, we would get the same answer. So, I don't know if you picture this, but you can use the change in x in order to solve for this horizontal side length. In other words, x2, so minus x1. And this would be x2 would be 6 because it is this point right here, minus x1, which would be 3 right here, and you would get 3, which is the side length. Now it doesn't matter if you do 6 minus 3 or 3 minus 6. Because even if you get negative 3, which is a negative number, you're then going to square it to find this side, the hypotenuse, and you're going to get a positive number either way. So truly it does not matter. Now, you might be asking, what about this side? It's not horizontal, it's vertical. Yes, and that is exactly why instead of using the x values, we would use the y values. So the y values, now we would use the y value of this point right here, this vertex, and this vertex. So let's go ahead and do this down here. This point over here has a y value of negative 4 right here. So negative 4. And then this has a y value of 1 right here. So negative 4 and 1. And then we would use the same idea, the change in y, in order to solve for this side length right here, right? So 1 minus negative 4, because it is y2 minus y1, although the order doesn't matter, as I explained, because you were going to square the number and get a positive number either way. So you would get 1 minus negative 4 simplifies into 1 plus 4, which would be 5. And now you know that this side length right here is 5. Now we know 2 of the smaller sides, so we can now find the hypotenuse using the Pythagorean Theorem, which would be a squared plus b squared equals c squared. Now we know that a, this side right here, is 3, but think about it. How did we get 3? Well, we used the change in x, right? So we could say that a is the change in x. In other words, x2 minus x1. So we could say that instead of a squared, we could say x2 minus x1 squared plus b squared equals c squared. Now we could do the same thing with y. Instead of saying b squared, we know that b is equal to the change in y, or y2 minus y1. So once again, instead of saying b squared, we could say, instead of saying b squared, we could say that y2 minus y1 squared equals c squared. Now we could take the positive root of both sides in order to solve for c, and we will get that c, or in other words, the distance, which we're gonna label as d, is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So this, you will see, is going to be referred to as the distance formula. And although it looks really messy and complicated, it is the same thing as a squared plus b squared equals c squared. It is just another application of the Pythagorean theorem. And I'm going to prove that by using this formula and plugging in these two side lengths that we have in order to solve for this. So we used x2 minus x1 in order to find one of the side lengths, which was 3. So let's do this right here. We have 3 squared plus, and we also used y2 minus y1, or the change in y, to find this side over here, which was 5. So 3 squared plus 5 squared, and then the square root of that whole thing. Now let's simplify this, and we will get that the square root of 9 plus 25. Let's combine like terms over here, and we will get the square root of 34, since it is 25 plus 9. And now the distance between these 2 points is the square root of 34. And we would get the exact same answer if we would have counted the side lengths. You see that it's 5, and then this is 3, and used a squared plus b squared equals c squared. So the wrap up, the takeaway here, is that the distance formula, which we have over here, is just another application of the Pythagorean theorem that you can use in order to find the distance between 2 points. Now, thank you so much for watching. Like and subscribe, and see you next week.